Hello and hi everyone. Do you guys ever wonder how magnets work? Today we will explore magnetism in a fun and easy way, specifically focusing on the magnetic force exerted on a single and two carrying conductors. In today's video on magnetism, I'm Yasmin, joined by Urdina, Alia and Arif. Together, we will explore the captivating world of magnetism. First, let me introduce magnetism. Magnetism can be characterized as a fundamental force in the universe that acts at a distance. It results from the motion of electric charges, particularly the spinning of electrons within atoms, which produce a magnetic field. Some magnetic materials such as steel, nickel, and cobalt can become magnets when exposed to a magnetic field. Do you guys ever wonder why magnets attract certain objects and repel others? Well, magnets have two distinct poles called the North Pole and the South Pole. Opposite poles will attract each other while like poles will repel each other. Moreover, magnetic field can be defined as area around a magnet where its magnetic force can be detected. It is a vector field, meaning it has both direction and magnitude.
So now, I am going to explain about magnetic force on a current carrying conductor. When a current carrying conductor is placed in a magnetic field B, a magnetic force will act on that conductor. The magnitude can be calculated by using this formula here, which is F equals to B I L sine theta. While the direction of the magnetic force can be determined by using Fleming's left-hand rule and right-hand palm rule, where thumb represents the direction of force, first finger represents the magnetic field, and the second finger represents the current. Let us see a demonstration of current carrying conductor with a mock-up magnet. The current carrying conductor is now placed in a magnetic field that is produced by the magnet, with the direction of the magnetic field strength is going into the wall. By using Fleming's left-hand rule, the direction of the force exerted on the wire is going upward, thus the conductor will be lifted. Now, let's learn to apply the formula. From example 6.8, a current I, 18 ampere, is placed along the positive x-axis and perpendicularly to a magnetic field. The conductor experiences a magnetic force per unit length of 0.12 Newton per meter in the negative y direction. Determine the magnitude and direction of the magnetic field strength in the region through which the current passes. First of all, list down all information from the question. Now, let us find the magnitude of the magnetic field strength B. By using F equals to B I L sine theta, we will get the magnitude, which is B equals to 6.67 exponent negative 3 Tesla. And lastly, let us find the direction of the magnetic field strength by using Fleming's left-hand rule. Thus, magnetic field strength B is in the positive z-axis direction.
A conductor that has a current creates a magnetic field around itself. When the current carrying conductors are placed close together, each will exert a magnetic force on each other. The force is attractive if the currents have the same direction, while the force is repulsive if the current have opposite direction. For the case of the same direction of the flowing current for two conductors, wire 1 produces magnetic fields that will make wire 2 to be inside the magnetic field of the wire 1. At the side of wire 2, magnetic field is going into the page. Same thing applies to wire 1 that is caused by wire 2, but the magnetic field is going out from the page. By using Fleming's left-hand rule, the force will be attractive. For the case of the opposite direction of the flowing current for two conductors, the both sides of each wire have the same direction of magnetic field. Both sides show that the direction of magnetic field is going into the page. By using Fleming's left-hand rule, the force will be repulsive. From the question, we know that both conductors have the same direction of the flowing current. Question asks to find the magnitude of the magnetic force per unit length for both current. We just need to substitute the values into the formula and we will get the answer. For the next question, both conductors has current flowing in the same direction. Thus, the force for the conductors are attractive.
The study of magnetic forces on conducting wires highlight key principles of electromagnetism essential for technologies like motors, generators and power systems that power daily life. From an Islamic perspective, understanding these natural laws enhances our appreciation of Allah's creation, reflecting a harmony between scientific inquiry and spiritual reflection and showcasing the divine wisdom in the universe.